Hello guys, welcome to another video of Problem of the Day series of GFG and LeetCode Problem of the Day. So the problems are insert an element at the bottom of the stack and find the duplicate number. So the problem statement, so first I will be taking a GFG problem of the day. So the problem statement is you are given a stack ST of n integers and an element x. You have to insert x at the bottom of the given stack. So we will be given a stack and we have to just insert an element at the bottom of the stack. Now, the notice everywhere in this problem, the bottommost element of the stack is shown first while printing the stack. So, for a GFG, for this showing perspective, it is printing the stack as last element will be first, and our first element will be as last. This is just for the printing purpose. In our stack, it will be stored as 8, 1, 2, 3, and 4. So consider this 4 as last element, and then we have to enter a 2 after 4. So as you can see in output, the output is 2, 4, 3, 2, 1, and 8. Because 2 is our last element. As you can see the second example, the output is 4, 5, 3, 1 because the element is 4 and in stack we have 1, 3, and 5. The constraint given are n is between 1 and 10 raised to 5 and our element of stack are between 0 and 10 raised to 9. So let's go to the explanation. So in this case, what first of all, what we need is we need our element of our first step to be reverse order. Why we need this in reverse order? Because our last element we want it at first place, so that we can enter a two on above of that element. So if all of the elements of the stack are in reverse order, then we can use this to handle our problem. So if all of the numbers are in reverse direction, we will add a 2 in it, and then we will again do a reverse of all of these elements so that 2 will be at the end of the stack. So we can achieve this using another stack or another stack storage. So this is our uh, original stack. The original stack, the elements stored are 4, 3, 2, 1, 8. It will be 1, 2, 8, 1, 2, 3, and 4. In the step 2, this is our original array. And for the reversing of the array, we have used another stack which will store all the element in its reverse direction. So our 4 is at first position, 3 is at second position, 2 is at this, 1 is at this, and 8 is at last position. Now what we will do, we will add it to above the above 4 using std push operation. The push operation we add 2 above of the 4. So this is our original stack and this is our stack storage. Now in the last step, what we will do, we will empty our stack storage and we will enter all of its element to the original stack. So it will give all the element in reverse direction and our the x element given to us will be at its correct position. So this is the explanation for this problem and this how we can achieve it. So let's go to the code of it. So in the code, you can see that I have initialized a stack storage. So this will be our cache stack. Now, until our original stack is not empty, we are pushing the element in our ST storage, and then we will add our storage X element at the top of the our dummy storage or our cache storage. Now, after that, in the third operation, we will do a while loop, which will ensure that all the elements are in our original stack given to us. So while ST storage is not empty, it will push the element from ST storage to ST our original stack, and then we will return our stack. So the time complexity of this approach is big of n, and the space complexity of this approach is big of n. The space complexity is big of n because we are just using n space here, because we are just using n stack here. And in the time complexity of this approach is big of n because we are just in all of this file loop, we are just iterating over all the elements. So proceeding to our next problem of find a duplicate number. So the problem statement is we are given an array of integer nums containing n plus 1 integers. Each integer is in the range 1 to n inclusive. Inclusive means from 1 to n we all our from 1 to n all the element between 1 to n and 1 and n also will be in our array. There is only one repeated number in the nums. Return this repeated number. You must solve this problem without modifying the array nums or use only constant extra space. So, first of all, in this problem, the repeated number can be repeated more than once, twice, or thrice, because it is not mentioned that it is just repeated twice. So, in the example given, the nums array is 1, 2, 1, 3, 4, double 2, and our output is 2, because 2 is repeated twice in this. Then our nums is 3, 1, 3, 4, 2, and output is 3. It is given as 3 and 3 here. In our example 3, we will have our nums. We have our nums as all the elements as 3 and our output as 3. The constraint on the n is between 1 and 10 is to find the nums dot length is n plus 1 and the elements in the nums is between 1 to n. Now here is the explanation that, or here's the note that I have given to you. All the integer in nums appear only once except for precisely one integer which appears 2 or 3 times. Okay, so there are many solutions to this problem. We can use a set, we can use a hash map, we can use Floyd's slow and fast pointer, we can use a binary search for this, or we can use a method to find out the problem. I will explain in this video. Uh, but in this video, I have mostly focused on two problems, two explanations, because I found that they are the most intuitive one, or they are the good problems. Rest of the problem using map, using set, we can do it easily. So going to the explanation. So our first will be a method in which we will find a number using subtraction of that number. So means this is our array 31342. Okay. So this is our array 31342. Now I is 0. So by explaining the solution, I will also explain why we are using this method. So the array becomes I equal to 0. So 3, 1, 3, 4, and 2. So I is at 0, so I will be at 3. So what we will do is we will do a nums of index equal to minus nums of index. Means the nums of index is 3. So at what position 3 is? So 3, 0, 1, 2, 3. So 3 is here. So we will do a nums of index equal to minus nums of index. So at 3 we have a positive 4, then we will put a negative 4 there. As a problem statement is given that we can't modify or we can't use extra space, but for the explanation for this problem, because it's a good uh, it's a good explain because it's a good solution, I think we can use a modification here. So we have put a minus 4 here. Then I is 1. So nums of index which is so now you can nums of index which is 1, we will do a minus 1 there. We will do a negative of that element. So 0 and 1. So this is the same element. So we will do a minus 1 there. Now in this array you can see our I becomes 2. So at 3 it will be so which index is stored at 3? So it is 4. So the 4 is already in negative. That means we have found a number which in the past we have found a number which is making him negative. Again, a similar number which is making him positive. That means that index is a repeated number. Because see that once a number is negative, we are sure that it is found out by some other index. It is found out by some other element. If it is, again we are finding that again we are visiting that element, it means that some other element had already visited him. So as we are visiting him twice, we are sure that the element which is making him positive again is our answer. So this is our explanation for this problem. So we can also achieve it using so I will wait a minute. So we can achieve this using another array or a extra. We can use achieve it using extra space. So what we will do is So this we will make an array of all zeros, and what we will do is we will iterate our I. So as you can see at 3, we I if I is 0 at 3, what we will do is at third position we will 0, 1, 2, 3, and 3. At third position we will do up 1 year. Sorry. We will make a 1 year, and then I will become 1. So what we will do at 1, we will make a 1 year. Update our value from 0 to 1. At 3, so now I is 2, which is 3. So at 3, 0, 1, 2, 3, now we find out that it is already been made by 1 from some other element in the past. So we know for sure that this element 3 is repeated twice, and this will be our result. So going forward to his code, so as you can see, I have initialized a uh, as 0. I'm iterating over nums.length. Now, why I've used this math.abs because uh, we are using its index in the nums. As in indexes cannot be negative, if we use an index it's negative, it will give an index out of bound error. So we are making and from its negative, what math.abs will do, it will make the element from negative to positive. So the index we will get is positive. Now, if the nums of index minus 1 is lesser than 0, means the element, if it is negative, then we will return its index, indicating that this is our answer. And if not, then we will do a nums of index minus 1 equal to minus of nums of index minus 1. And if it doesn't find any of the negative repeated element, in this case we will definitely find as a problem statement. But if we don't find it, we will return minus 1. So this will be code for this problem. Now moving towards the another another solution, solution number 2, which is using Floyd slow and fast pointer. As you have used this Floyd slow and fast pointer in the uh, linked list to find the cycle of the linked list, so we will use a similar concept here to find a repeated element. So as you can see, this is our array elements 3, 1, 3, 4, 2. Now we will initialize our slow and fast pointer to 0 location. Now, what we will do is we will move our slow pointer to at pace of 1, and we will move our fast pointer at pace of 2. So our slow will be equal to nums of slow, and our fast will be slow equal to nums of fast. So as you can see here, the slow is at 3. So nums of 3 is 4. The our slow is at 4. Now our fast will be nums of 3, which is 4, and nums of 4, which is 2. So fast is at 2. Now our slow will be equal to nums of 2. So it will be at 1. Sorry, it will be at 3, 0, 1, and 2. And our fast will be at 4. First it will be at 2, and then it will be at 3. Now we have found a position where slow and fast pointer meet each other. So this will be our first step. In our second step, what we will do, we will use the similar approach, and we will find a number which intersect between the node, in which intersect. So as you can see this, this is our so we will initialize our slow pointer again to 0 position. We will move forward. Uh, we will move both of the element at pace 1. So our slow is at 3. Slow is a zero pointer, so zero index. So nums of slow will move it to here, which is 3. And our fast is at 3. So nums of 3 is at 3. So fast will already at 3. So it will be at 3. And in this case, slow and our slow and fast pointer mirror each other. So we know for sure that definitely this will be our result. So moving forward to the code, we have initialized our slow and fast pointer to nums of 0. And then we will use a do while loop. Why we are using a do while loop? Because we have already initialized our slow and fast pointer to nums of 0. They are at 0 position. So if we use a while loop, it will not go into this loop. So hence we have used a do while loop. So our slow will be equal to nums of slow, our fast will be equal to nums of fast, and they will meet at certain position. Now, why they will meet a certain position? Because there is a cycle. Because a number is repeated, then we will know for sure that there is a cycle in these elements. So there will be a certain position where slow and fast will definitely match. Now, we will initialize our slow to nums of 0 again. I will move our slow and fast at pace of 1. Slow equal to nums of slow and fast equal to nums of fast. Now this while loop will make sure that they meet at certain position, and that position will be our answer. So the time complexity of this approach is big of n and the space complexity of the approach is big of 1 as we are as we are not using any of the constant space. So that's it for today, guys. I hope you have understood the explanation of both the problems. That's it for today. Stay tuned for next video. Thank you.